So in this paper, we develop a wealth analysis of change in notches using evidence from the Bolsa Família program. So uh, we actually do two things in this paper. The first one is that we develop a novel sufficient statistic framework to bound the welfare impacts of reforms that changes notches, right? Um, and we show that there are two sufficient statistics in such settings. The first one is B, where the number of households that were bunching at the old notch and moved towards the new notch because of the reform. And the second one is J, the number of households who jumped down to the new notch because of the reform. And our framework is actually pretty general, so we allow for different behavioral margins, such as labor supply misreporting, um, using arguments similar to the one in the usual approach of the sufficient statistics. We also allow for behavioral biases, dynamics, frictions. But in particular, our method allows us to analyze the welfare impact of notch reforms and arbitrary large reforms, which are two things that actually um, precludes us from using the usual envelope theorem argument, um, and and we and but it allows us to be more general than the usual approach. So to understand how this, the second thing that we do in the paper is that we bring our bounds to the data, bounding the welfare impact of a Bolsa Família reform that is illustrated in this figure. So in the horizontal axis, I'm showing here the reported income y hat, and in the vertical axis, we're showing the benefit level B. And before the reform, the schedule faced by households were the one in the light blue line, such that they got a benefit of 70 reais if they report income below 70, and the reform increased both the threshold of eligibility and the benefit of the program in 7 reais. So the notch moves outward. And we estimate these statistics for 2014 Bolsa Família reform and provide bounds for the reform's marginal value public funds (MVPF). So the definition of MVPF is just the ratio between the willingness to pay for the reform and the cost of the reform. And as pointed out by Hendren, that's a key parameter for us to conduct the welfare analysis. Um, so in the baseline model, we're gonna derive bounds in a world in an economy where agents actually respond with misreporting. But we're gonna show afterwards that the bounds hold in a much more general model. So to understand intuition in the baseline model, let's consider a government that offers a policy P, which is determined by the benefit level B and the threshold of eligibility tau, such that households they receive the benefit B if they report income y hat below or at tau. Um, Households are endowed with an exogenous income level in this baseline model, y, and they choose only how much to report. They choose y hat. But they do face a misreporting cost, which is increasing with the size of the misreporting. So in that model, some households misreport in bunch of tau, but some households will always report their income because their misreporting cost is so high. They're always truth tellers. So in such a model, we would have the following density of income and reported income distributions. In the left hand side graph, I'm plotting real income in the horizontal axis and density in the y-axis, such that if we postulate that this exogenous distribution is decreasing, the implied reported income distribution that we observe in such a model would be the one on the right hand side of the graph. And the way to see this is that for households that have real income below tau, there's no misreport incentives, and therefore they're just going to report their true income, and those two densities are going to be the same. For households with income like high enough, there's also the misreporting costs are too high and nobody's going to lie, so everyone's going to report their true income, and those distributions are going to be the same again. But for households in this middle range between tau and YC, where YC is the critical income level, such that households are indifferent between reporting the true income or jumping down and reporting at tau, um, these households, part of them are actually jumping to the program in bunch at tau. Part of them are those always truth tellers that always report their true income, and they're going to be here in this valley. And that's going to generate this missing mass, right? Like these bunchers are coming exactly from this missing mass between tau and YC. So to understand the welfare impact of the reform, we're gonna consider reforms just like the one in the Bolsa Familia, that changes the policy P from B and tau to P prime, which is equal to B prime tau prime, for an increase in policy, right? For P prime greater than P. And we're gonna determine the willingness to pay for the reform. So the first step is to note that for households that don't change the behavior, the willingness to play is just the increase in benefit, right? Like, if you're not changing the behavior, the only thing that um, is affecting your willingness to pay for the reform is just how much more you get for benefit. Um, but for the households who change their behavior, it's a little bit more complicated because the envelope theorem does not hold. In particular, first we want to consider a policy change of any size, right? So we don't want to rely on infinitesimal arguments. But the second reason is because utility in the case of notches is not continuous in the policy, right? And even in the most general version of Milgram-Segral for the envelope theorem, you still need that assumption to apply for the envelope theorem. So for those two reasons, we need to calculate the willingness to pay for those who change their behavior, and we're gonna do so bounding their willingness to pay using a review preference argument, and that's gonna allow us to bound the MVPF. So here's the key intuition for why we can construct the bounds on the or how we construct the bounds on the willingness to pay. For that, it's helpful for us to define two willingness to pays or willingness to pays in under two different scenarios. The first one is the actual willingness to pay, which is going to be WTP of P and P prime, which is the willingness to pay for a reform that changes the policy from P to P prime in the actual world. The second one is going to be this counterfactual willingness to pay, or CWTP, of P and P prime at Y hat. So this is the counterfactual willingness to pay for a reform that changes the policy also from P to P prime, but now holding the decisions of the agent constant at Y hat. So the first thing we note is that the willingness to pay, the actual willingness to pay, needs to be larger than the counterfactual willingness to pay at Y hat of P, that is, at the reporting choices before the reform. And the reason for that is because under the actual scenario, households, they actually re-optimize after the reform. And for that reason, they need to be willing to pay more for the reform under the actual scenario in which they re-optimize than in this counterfactual scenario in which they are not allowed to re-optimize, and therefore the utility increases less. Um, so that's how we create the lower bound. The upper bound is analogous, right? We show that we argue that the willingness to pay for that policy change cannot be greater for the counterfactual than the counterfactual willingness to pay for the same policy change, holding constant the decisions at Y hat of P prime, that is at the reporting choices after the reform. And that's because before the reform, the households are already optimizing, and for that reason, the utility before the reform in the actual scenario is going to be higher than in the counterfactual scenario. And the utility after the reform is going to be the same because in both scenarios they're choosing Y hat of P prime. And therefore, it needs to be the case that the increase in utility in the counterfactual scenario is higher, and households cannot be willing to pay more than this counterfactual scenario. Uh, and that's how we create the upper bound for the willingness to pay. So now we go back to this graph in which we're plotting the reported income in the horizontal axis and the density that we would observe in the baseline model in the vertical axis. And we are going to consider what would happen with this distribution under reform like the one we see in the Bolsa Familia program. So there would be two behavioral movements of the income distribution. The first one is a spread of the households that were originally bunching at tau towards tau prime. And the second one would be the jumps that would happen for households that were located between YC and YC prime, where YC prime now is the critical value of income, such that households are indifferent between reporting the true income YC prime or misreporting and bunching at tau prime after the reform. So for these households that were between those two critical values, they were better off telling the truth beforehand, but now they're going to be better off misreporting and bunching at tau prime. Um, for Those are the two movements that we will observe with the reform, which means that actually we can organize the set of households that are affected by the reform in four groups. So the first one are the mechanical households. So those are the households that have reported income below tau, both before and after the reform. Second one are the bunching households. So those are households with the first behavior response. Those are households in the pink bar here that spread themselves between tau and tau prime with the reform. The third group is going to be the threshold households. So those are households that always report their income truthfully between tau and tau prime, but because of the reform, they mechanically become eligible to the reform. And the fourth one are the jumping households, households that were originally located between Y and YC prime, and they jump into the program towards tau prime because of the reform. So now let's think about both the cost and the bounds and the willingness to pay for each one of those households. For the mechanical households, they cost the program B before the reform because they are eligible, and they cost the program B prime after the reform. Therefore, the cost of the program is just B prime minus B. And as we mentioned before, the willingness to pay for households that do not change their behavior is just their increasing benefits. So both the lower bound and the upper bound is going to coincide with B prime minus B, which is just their increasing benefits. Now for bunching households, we actually need to make this calculation because they do have a behavior response, right? So the cost of the program is also going to be B prime minus B because these households are also eligible before and after the program, right? They're just moving from tau towards tau prime. However, to compute the lower bound of the willingness to pay, we're going to have to calculate the counterfactual willingness to pay at y hat of p, which in the case of bunching households is just tau. But at tau, they're also eligible before and after the reform, and therefore they would be willing to pay b prime minus b if we hold their decision constant at tau. Now, their upper bound to the willingness to pay is going to be b prime because we need to hold constant the decisions at y hat of p prime, which for the bunching households is tau prime. And if you hold the decision or is some income level between tau and tau prime, for any of those income levels, if you hold the decision constant at those levels, these households, they become something like a threshold household, right? So they're mechanically gonna only get the benefit after the reform, but not before. Therefore, they're gonna be willing to pay in this counterfactual scenario the full amount of the benefit after the reform or B prime. For the threshold households, they are also not eligible before the reform and they are eligible after the reform. So each one of them costs the full amount of the benefit after the reform or B prime. They don't have any behavior responses, and therefore the willingness to pay is going to be equal to the lower and the upper bound. It's just going to be the increasing benefits that they face, which is B prime. For the jumping households, they cost the program also B prime because they're not eligible before the reform, but they become eligible after the reform. Now, the lower bound of the willingness to pay or the counterfactual willingness to pay that they would face holding the decision constant at y hat of p, which in the case of this jumping households is some income level between YC and YC prime, would be zero, right? Because they're not going to be getting any benefit nor before nor after the reform. And finally, their upper bound of the willingness to pay is going to be once again B prime, and that's just because y hat of p prime for the jumping households is just tau prime, and at that income level they're only eligible after the reform, not before, and they were going to be willing to pay the full amount of the benefit after the reform, which is what they get from the reform. So with those are all the elements that enter the MVPF, right? Once again, the MVPF is just a ratio between the total willingness to pay and the total cost of the reform. So this means that we can actually bound the MVPF with these two inequalities, right? And it's very intuitive to understand where these inequalities come from now, because we know that the total cost of the reform is going to be given by this sum. So we're just basically summing the increasing benefits times the number of households that actually were eligible both before and after the reform. So those are the mechanical households and bunching households, plus the full amount of the benefit after the reform times the number of households that only become eligible to the program after the reform. So those are the threshold households and the jumping households. So the lower bound for the marginal value of public funds is going to be determined by the lower bound of the willingness to pay. But we know that the willingness to pay, the lower bound of the willingness to pay is equal to the cost for all the households except for the jumpers. They have a lower bound equal to zero, but cost of the program be prime at the lower bound, right? So if you want to construct the lower bound of the willingness to pay from the total cost, all we need to do is going to be to subtract b prime times j, which is exactly what appears here on the left-hand side of this inequality, determining the lower bound. Now, if we want to construct the upper bound, we come from the observation that for all households, the upper bound of the willingness to pay coincides with with um, um, with the cost of the program, except for bunchers, because for bunchers, the upper bound of the willingness to pay is going to be B prime, but um, they only cost the program B prime minus B because they're eligible both before and after. So if you want to construct the upper bound of willingness to pay from the total cost, what we're going to have to add is this term here, right? Is the B times the number of bunchers, which is exactly what the term that appears in the numerator of the upper bound, which is the willingness to pay upper bound. Now, this proposition, even though we gave the intuition of this proposition in a simple misreporting model, it's is way more general than that, right? In particular, if we allow for households responding to different margins, like, for example, labor supply, frictions, misperceptions, heterogeneity preferences, multi-agent households, the result's still going to follow through. Now, we also show that the bounds they hold for a dynamic model, but now we will need not only J and B, but also the expected J and B for all periods after the reform. We showed that we can amend the model to allow for other physical externalities. The fact that the program can generate externalities on other tax revenues for the Brazilian government. But in that case, we'll need to measure these externalities, of course. And finally, we highlight in the slide that in this more general model, J and B are no longer the number of bunchers and jumpers. J now becomes the increase in the number of households eligible under the new schedule because of the reform, and B becomes the decrease in the number of households eligible under the old schedule because of the reform. So to get the intuition for this generality, I think it's helpful for us to think about um, a model in which agents are facing an arbitrary choice set. So, for example, this choice set could be in a household with n members. It could be the labor supply of each one of these n members, but also the misreporting choices of each one of those n members. Now, it's important to note that even in this very general model, households, the choices that households have will imply a household reported per capita income y hat, which is the variable that's going to generate the eligibility to the Bolsa Família program. So there's still only two groups that respond to the reform, right? So the first one is B. So those are households that were anywhere below the threshold of eligibility tau per reform, and they move towards tau and tau prime. And the second one is J. So those are households that jump anywhere into the program because of the reform. Now, for the group B, the cost of the program is still going to be B prime minus B because they're eligible both before and after the program. And the lower bound is still going to be B prime minus B because if you hold their decisions constant there, the entire vector of the decisions XP constant at XP, they are going to be reporting both before and after the program Y hat of P, right? Which means they're going to be eligible both before and after the program. Now, if we construct the upper bound, which is holding, it's a counterfactual willingness to pay holding constant their decisions on X of P prime, for this B households, that implies a reported income between tau and tau prime, and therefore they're only going to be eligible to the program after the reform, and they're going to be willing to pay the full amount of the benefit after the reform, which is going to be B prime. So the upper bound is the same as before. Now, for the jumping households, right, or for this J households, I should say, in the general model, they also cost B prime because they are not eligible before the program, but they jump into the program because of the reform. So their lower bound, the willingness to pay, is going to be the counterfactual willingness to pay evaluated at X of P, which in the case of this households is just this income level outside of the program, and therefore they're not going to be eligible nor before nor after, and they're going to be willing to pay zero for the reform. And the upper bound, once again, coincides with B prime. Now, for all the other groups of households, the upper and the lower bounds, it's going to equate the cost, right? Because all that is going to change in their willingness to pay for households that don't change their behavior is going to be the increase in benefits. So this is exactly the cost of the program for each one of those households. So because of that, the MVPF bounds construction is going to be exactly the same as in the baseline model, and we can use the same argument as before. So in this last couple of slides, I just want to show how we implement this in the Brazilian data. But I'm going to be fairly quick here because this is a much more standard exercise. Um, so what we do, what I'm showing here in this left-hand side graph is the log number of households that report in the interval between 63 and 70 on each month of our data set. And I'm I'm indicating the months between the announcement and the enactment of the reform in this gray bar. And you see here in the red line what happened in the actual world. And in this lighter red line, we're constructing counterfactual number of households that were located at that interval had the reform not had happened. Um, if the reform didn't happen, and in that that is constructed using a generalized difference in difference approach that you can take a look in the paper if you're interested. But what's important to note is that those households getting out of that interval are exactly the households that we're calling the bunching households, right? So those are households that are moving away from 63 to 70 towards the new threshold because of the reform. The second group of households that we're interested in are the ones moving towards 70 and 77. So once again, we plot in the dark blue line the actual log number of households reporting at that interval in each month of our data set. And in the lighter blue line, we're constructing this counterfactual log number of households reporting at that interval um, in the scenario that the reform didn't happen. And you see here there's a huge increase in the log number of households after the reform. And and that implies actually, if we look at the data, that there were 27,000 families um, that moved away right from this interval 63 and 70, which is exactly the bunchers, and there was an increase of 49,000 number of households that located themselves between 7 and 77, which are not only the jumpers, right, that jump into that interval, but also the bunchers that are coming away from 63 and 70. So that actually implies the number of jumpers is going to be 49 minus 27,000, which is 22,000. So in that way, we're actually able to estimate the bounds for the MVPF, and we found using the formula that we derived a couple of slides ago that the MVPF is bounded between 0.9 and 1.12. Because this is basically the willingness to pay for $1, one marginal dollar spent on the reform, we can say that this reform increased the welfare in Brazil with a value of 90 cents to the Bolsa Família, more than R$1 given to the best alternative, but the welfare in Brazil decreased if we value 1.12 reais given to Bolsa Família beneficiaries less than R$1 in to the best alternative. Now, we don't know what's the best alternative, but we just to make some concrete welfare statement, we assume we impose more structure in the problem, and we assume that the best alternative is a non-distortionary UBI, and we use a conservative back of the envelope calculation to find that spending R$1 on the Bolsa Família reform has a welfare gain that is equivalent to spending 1.5 reais on a university basic income. So if the best alternative is UBI, what we show is that Bolsa Família's welfare improving.